Dear students of Middle 2, we will study the wave motion. Sure, you have observed if you throw a small ball in a basin of water, the water surface gets disturbed. This disturbance doesn't remain confined to one place, but propagates outward along a circle, as you can see. It gives a feeling as if the water is moving from one point of a disturbance. In the same way, if you fill a trough of water and place some paper balls in it, dynamic ripples on the surface of water by using your finger, you will observe the occurrence of disturbance in water surface in the form of circles. And paper balls move up and down, as you can see, as the wave passes, but they don't travel along the wave propagation. So we can say that the particles of the medium just vibrate up and down and around their mean positions. Just vibrate up and down around their mean positions. These particles collide with the neighboring particles and transfer energy. As a result of these neighboring particles vibrate and also transfer energy to the other neighboring particles, which in turn begins to vibrate. This process continues and energy is transferred from one particle to the other particles of the medium. Such motion is called wave motion. In this case, we can define the wave as the disturbance that propagates and transfers energy in the direction of wave propagation. On the other hand, the definition of wave motion is the motion produced as a result of the vibration of the medium particles at a certain moment in a definite direction. So we can say that in wave motion, medium particles don't move from their positions, but they vibrate only. The wave propagates, carrying the energy in the same direction of its propagation. But here, waves can be classified according to their ability to propagate and transfer the energy, and also can be classified according to the direction of vibration of the medium particles. When we divide the wave or classify waves according to the ability to propagate and transfer the energy, we can divide them into two types: mechanical waves and electromagnetic waves. Mechanical waves, like the sound waves, for example, the sound of your voice propagates in the medium of air. It needs a medium to propagate through. While here, on the other hand, we have light wave, which here can propagate through space, doesn't need medium to propagate through. And also the waves are classified into two types according to the direction of propagation, into two types. Here, this type, which is called transverse wave. As you can see here, the particles of the medium vibrate perpendicular to the direction of the wave propagation. This is called transverse wave, consists of crests and troughs, like waves in water, waves on string, and light waves. The other type of waves is called longitudinal wave. The vibrations are parallel to the direction of the propagation of the wave. Longitudinal waves consist of compressions and rarefactions. Once more, we say that waves are classified into these two types: transverse and longitudinal wave. Transverse wave and longitudinal wave. Let us to see here the difference between them, starting with the longitudinal wave. As you can see here, the particles of the medium vibrate along the direction, in the same direction of wave propagation, in the same direction, where some molecules of the wave, for example, some molecules of the medium, which is the air, become compressed, which this area is called compression, and the other become apart from each other, which are called rarefaction. Like here, the wave of the sound. The waves of the sound, for example, produced from a drum, as you can see here, are produced as pulses of compressions and rarefactions, as pulses of circles, whose center is the sound source, which is the drum, for example, here. This is the source of the sound. Other type of the wave, which is transverse wave. Observe here, the wave moves what particles move perpendicular to the direction of the wave propagation with an angle 90. Okay, it consists of the highest point, which is called the crest, and the lowest point, which is called the trough. So it moves perpendicular to the wave propagation, as you can see here. So we can define transverse wave as it is a disturbance in which the particles of the medium vibrate perpendicular to the direction of wave propagation. And transverse wave consists of crest, which is the highest point of the wave, and the trough, which is the lowest point of the wave. An example of transverse wave is light and water. Light and water waves are transverse waves. On the other hand, longitudinal wave is a disturbance in which the particles of the medium vibrate along the direction of wave propagation, and it consists of areas in which the molecules become closer to each other, become compressed. This area is called compression, and other areas in which the molecules of the medium become apart from each other, which is called rarefaction. So transverse wave consists of crest and trough, while longitudinal wave consists of compression and rarefaction. The example of transverse wave is light or water. The example of longitudinal wave is sound wave. Once again, we make a comparison between the longitudinal wave and transverse wave to know the difference between them, as you can see here. That is the difference between transverse wave and longitudinal wave according to the direction of wave propagation. So if you are given a question, give reason. Light is considered as a transverse wave. You should answer because the particles vibrate perpendicular to the direction of wave propagation. In contrast, if you are asked, give reason, sound is considered as a longitudinal wave, you can answer because the particles vibrate along the direction of wave propagation. That is the difference between the types of waves. And also the other types of waves, as we said, which are electromagnetic waves, which don't need medium to propagate through. They can propagate through vacuum with high velocity, reaches about 3 times 10 power 8 meter per second, like light and radio waves and infrared rays. On the other hand, the mechanical waves, which here need medium, it must be present a medium for them to propagate through, like sound waves and water waves. These are the types of waves and the concepts of wave and wave motion in this lesson. I hope you understand this part of the lesson. Thank you, my dear students, and goodbye.